Hello everyone, welcome back to the another session in design and analysis of algorithms. Today we are going to learn about optimal storage on tapes. This topic you will find in third unit as topic number 4. Let's get started. Now this video will be going to deal three things. The one is what is optimal storage on tapes problem, what it is, how to solve this problem, and we'll see even one example from previous question paper. Right now, what is optimal storage on tapes problem? So the name itself, it tells that you are going to take some tape to store some data. Okay, now this storage is what n number of programs. That means you have to assume there are n programs that are to be stored on a computer tape of length L. Associated with each program, I is a length Li. That means assume that my n programs are is equal to 3. I1, I2, I3. My each job or my each task is having length of L. That means I is always lies in between 1 to n. Now, clearly, all the programs can be stored on the tape if and only if the sum of the length of the program is at most L. We assume that whenever a program is to be retrieved, n is equal to 3. Now, I wanted to store all these 3 programs on this tape. Now, let us assume these 3 are what? I1, I2, I3. Now, I am placing here I1 and I2, I am placing I3. Now, assume that whenever a program is to be retrieved from this tape, the tape is initially positioned at the front. So, I'll give an example to understand in better way. If you wanted to listen the song, so you will be having some tracks, right? So one track is consisting of some 6 number of songs. So when you wanted to listen all these 6 songs, you will be starting with the song number 1. Okay? And to listen the song number 2, you have to finish song number 1. If you wanted to listen the song number 3, you have to listen song number 1 and song number 2. Then only you can listen song number 3. You might have understood with this example, right? And that is what I am specifying very clearly. Whenever a program, either that may be of I2 or it may be of I3, a program is to be retrieved from the tape is initially positioned at the front. Hence, if the programs are stored in the order I1, I2 up to In, that is non-decreasing order, the time Tj is needed to retrieve the program Ij is exactly proportional to sum of 1 less than or equal to k less than or equal to j Lik, right? And this is what the retrieval time. If you do not keep all this in non-descending order or else ascending order, now how many permutations you will be having, correct? Now, let's see with the example. In the optimal storage tape problem, we are required to find a permutation for the n programs. N is equal to 3, I1, I2, I3. Now, we are required to find a permutation for the n programs so that when they are stored on the tape in this order, the MRT means what? Mean retrieval time. Mean retrieval time is minimized. Now let's see. I have these 3 tasks which are available on the tape. That means I stored already, but I wanted to retrieve it back. So I can retrieve it as I wanted to start with the initial position. So I told you already in the previous example why the way I have to start with from the initial position. So that we were seen, right, in the just before slide. Now, So when I wanted to get I2 I wanted to retrieve. So for sure I have to retrieve the 1. Then only I can go for 3. 1, 2, 3. Or else 1, 3, 2. In this order also you can have a retrieval. Or else 2, 3, 1. All these are permutations, right? 2, 1, 3. 3, 1, 2. And 3, 2, 1. All these are possible permutations to retrieve the data or the programs which are available on this tape. So now the point is what? If all the programs are retrieved equally often, then the expected or mean retrieval time is what? 1 by n, the number of tasks. Sum of I less than or equal to j less than or equal to n tj. So this is what your mean retrieval time formula. Now we'll see an example to solve some problem, how to store the data on the tape and how to retrieve. Our job is to calculate the retrieval time. So when you are working with the single tape, then you will find out the retrieval time. Okay. If you are working with the multiple tape, yes, it is true that you can also store the data in multiple tapes. That we'll see with an example. When you are using multiple tape, then you will be going to find out the mean retrieval time, because each tape will be having some retrieval time, right? When you have multiple tapes, T0, T1, T2 up to Tn, you will be finding out each individual retrieval time. So to get one final retrieval time, that means you will be calculating the mean retrieval time. So mean retrieval time formula is what? Sum of all the retrieval times, individual retrieval times by the number of programs, then you will get the mean retrieval time. So this is the way how you have to calculate one problem to retrieve the data from the tape. Now we'll see with an example to understand in better way. Now assume that there is a problem. Let n is equal to 3. That means what? Number of programs. Now each program will be having a length of L. That means L1, L2, L3 is equal to 5, 10, 3. Now each program is having length of L. We have to store these programs on this tape. Okay. So this is indicating with I1, I2 and I3. So I told you already that I can use single tape or I can use multiple tape. So for this example I am using single tape. So retrieval time always should be minimum. So you will be having many feasible solutions. Obviously you will be having many feasible solutions. So that feasible solution is what? The number of permutations to place on the tape and to retrieve the programs back. So what are the feasible solutions for this problem? I can retrieve my programs in the order of 1, 2, 3, or else in the order of 1, 3, 2, or else in the order of 2, 3, 1, or else 2, 1, 3, 3, 1, 2, 3, 2, 1. All these are what? The different permutations what are feasible from this problem. So now how to calculate the retrieval time? So you have to finish the complete length of this task, right? That means to retrieve this task number 1, means I have to finish this length. That means it is 5. Now in order to get access of 2, now I need this task to be done and this task to be done. That means 5 plus 2. Now the third task is what? Which is 5 plus 10 plus 3. Now these are what? 3 you have to calculate. Correct? So now again go for 1. 1 is what? The length is what? 5. Now to retrieve this third length, you have to finish first of all this 1 also, right? So that means 5 plus the third job length. The third job length is 3. Now to complete this 2, that means to retrieve the task number 2 from the tape, you have to finish in this order. That means 1 has to be get finished. That means 3 has to be get finished and 2 also should get finished. So you cannot access directly the task which you wanted to retrieve. Always, if you wanted to access the task, that means if you wanted to retrieve this task, you have to finish this and this. Until and unless you can't retrieve the program from the tape. That is very very important point what you have to keep in mind to solve this problem. So now 2 is my initial task. So to solve my initial task, I need not to perform anything. Only the length of this job I have to finish, which is 10 plus. Now this is the third job is in the place of second, right? On the tape, the third job order is what? 2, 3, 1 order. This is one of the feasible solution. Now to start with the 2, I am taking 10. 10 is what? The length of this 2. To access this 3, I have to finish 2. Then only I have to go for this 3. So the length of 2 is what? 10. And the length of 3 is what? 3. Now if you wanted to retrieve this 1, what is the length of 2? Again 10. The length of 3 and the length of 1. So this is the way you have to retrieve the job or retrieve the program from the tape. So when you do like this, what happens, you will be again and again, you will be taking that values into consideration. So to reduce this, we will be going to apply greedy method. Greedy method is what? Greedy method is a method where you can apply when the problem is having a constraint of minimization or maximization. So from this optimal storage on tapes problem, we always seek retrieval time is minimum. Retrieval time is minimum. So for whatsoever permutation retrieval time is minimum, that is the solution. So for this you need not to calculate all this. We'll use greedy method and we'll give a better solution. Now we'll see the same problem applying of greedy method. Now we'll be going to apply greedy method on the same problem. So how greedy method is applied on this problem is, first step is what? You have to make all the number of tasks in an non-decreasing order. Non-decreasing order. That means non-decreasing order means what? When you given with some values to be solved, so then we will arrange the programs in ascending order. That means a greedy approach to build the required permutations would choose the next program on the basis of some optimization measure. As far as the example is concerned, L1, L2, L3 is equal to 5, 10, 3. So before you apply greedy method, you have to make this non-decreasing order or else ascending order. Then your jobs were what? 3 is the minimum, 5 is the next and 10 is the next. That means 3 is what? Length of L3. That means L3. 5 is what? L1. And 10 is what? L2. So L3, L1, L2. Now one possible measure would be the D value of the permutation constructed so far. The next program is to be stored on the tape would be one that minimize the increase in D, delay time or retrieval time. If we have already constructed the permutations I1 to IR, then appending the program J gives the permutation I1, I2 dash IR and IR plus 1 is equal to J. That means you are appending the program to the appending the program onto the tape. This increases the D value by sum of 1 less than or equal to K less than or equal to R LIK plus LJ. Since sum of 1 less than or equal to K less than or equal to R LIK is fixed and independent of J, we trivially observe that the increase in D is minimized if the next program chosen is one with the least length from among the remaining programs. The greedy method or the greedy algorithm resulting from our previous discussion is too simple that we won't bother to write it out. The greedy method simply requires us to store the programs in non-decreasing order of their length. This ordering can be carried out in big O of n log n. So basically with all the permutations it gives the complexity of n factorial, correct? This is using greedy method. This is what the normal permutations what we will get with optimal storage on tapes problem. So just before in the example, when the task is equal to 3, how many feasible solutions you got? Total 6 feasible solutions you got, right? That means n factorial, which is 3 factorial 6. Now if I apply greedy method, as I am going to take non-decreasing order, the complexity will get reduced into big O of n log n, and this is what efficient sorting algorithm. Now we'll see that algorithm. Now algorithm, I'm taking some store function because I wanted to store the programs on the tape n comma m. Now so here I'm not going to take single tape. M indicates it is number of tapes, n indicates it is number of programs what I wanted to store on the tape. Now j is equal to 0, that means next tape what I wanted to store on the tape, next tape. Now I'm taking some iteration or for loop where I wanted to start with I value. My first job is getting placed on the tape. So when I is equal to 1, my first program will get append program, which is I, to permutation for tape j. Now if I have one more job to be append, then I put j is equal to j plus 1 mod m. Now this is very important, that this condition what I wrote is very important. That means, so we'll check the mod value of this j in order to append the program, correct? J is what actually next tape. Let us take this 1, 2, 3. Now so initially 1 is getting placed on the first tape. So this second is what? Second is my j is initially is equal to 0. 0 plus 1, that is j is equal to 1. And now we will be going to calculate the number of tapes. M is what? Number of tapes, and we'll find out the mod value to allocate the tape where I have to place this to. Okay. So this is the way how we'll distribute the task among your number of tapes. So we'll see with an example in the next video, and that the example is previous question paper OU previous question paper problem that we'll solve in the next video. So in this video what we will learn, what is optimal storage on tapes problem, so how to apply greedy method, what I have to do before I apply greedy method, and what is the algorithm. Thank you all.